Hey guys, nice to meet you guys. So right now we are on live, and we can start from here. Welcome to another BNB Revelation Hackathon project demo session. This is Chris from DoraHacks. I'm gonna be the host for this session, and it's my pleasure to host you guys today. Yeah, a little bit intro about the Revelation. It's the first hackathon that after BNB rebranding their whole ecosystems, and they have injected a lot of resources into this hackathon. Not only the prize pool, the seed funding opportunities, and also they have invited lots of great sponsors and judges from the industries. So they can provide very professional and useful advice for all the participating teams. And congratulations that you guys are one of them. Yeah, today we have 3 teams with us. They are Cryptosat, Seavoting, and AntDAO. So without further ado, let's welcome the first team to start, which is the Cryptosat. And Yan, feel free to start when you're ready.
Hi, thanks, Chris. So thanks, Chris and Christina, for helping to organize that, and to DoraHacks, who've been very supportive. And excited to be here, excited to be in this round. So yeah, let me quickly switch to sharing my screen.
Yep, we can see.
Awesome. All right, so yeah, so let's get into it. I have some slides to talk through it, and yeah, we'll explain what we do and what we're going to do moving forward. So essentially, Cryptosat is all about trust in space, and we're a project in the combination, in the intersection of cryptography and blockchain and space, like literally satellites. So our mission in general is to build satellites that power blockchain, crypto, and DeFi applications, and we're going to support it by placing the cryptographic root of trust in space to guarantee ultimate trust and transparency of sensitive cryptographic operations. And I'll explain in detail what it means. So in terms of some of the people on our team, the co-founders of the project are Jonathan Weintraub, who's bringing a lot of aerospace and satellite technology expertise, and myself. I'm coming from a PhD at Stanford University in applied security and privacy, and previously co-founded an enterprise security company called Anjuna. We also have space systems engineers on our team, and we have advisors who've been active in the blockchain space and in the crypto space, including Daniel and Omer, who was the co-founder of Zengo, which is a popular wallet. So just to show some of the achievements of Jonathan's, that's basically, that's a model that is currently on the International Space Station, and that's an experiment in agriculture in space, growing chickpeas under essentially no gravity conditions and testing that. And that's a back of the moon photo that was taken by spaceships. So Jonathan was previously a co-founder of an NGO in Israel that was essentially the first privately owned and operated mission to the moon. Before that, only countries and nation states were able to launch such missions. That was the first mission that essentially sent a spaceship to the moon, and that's one of the photos they've taken. The spaceship was called Bereshit. So essentially, Jonathan brings a lot of aerospace and satellite spaceship engineering expertise. Yeah, so in terms of what we're doing, what's Cryptosat, I'll explain the concept of crypto satellites, which is something we came up with initially as an idea in 2017, and then kind of went on our ways, did other things, and about a year ago got back to it and decided to actually productize it. So crypto satellites essentially can serve as a root of trust, a cryptographic root of trust. And what it means, there are sometimes sensitive cryptographic operations that require to trust in something, and you want to minimize the trust. You don't want to trust everything. You don't want to just say somebody anonymous on the internet to give you some I don't know, some cryptographic parameters to use because they can be backdoored potentially. For instance, you might be familiar with things like elliptic curve cryptography. So those curves those cryptographic parameters need to be generated by trustworthy parties. So we know some curves that we can use and we can trust them, but kind of that's just one example where you need to kind of trust something, and this trusted party better behave honest. Otherwise, the whole protocol or the whole cryptographic scheme can break. And there are many examples of that in cryptography. One example you might be familiar also is the ZK snarks, zero knowledge proofs. And they require ceremonies that generate something that's called a common reference string or a structured reference string. And those parameters need to be generated in a trustworthy manner. Otherwise, the whole protocol can break. So that's where root of trust is helpful. And then you want basically a computer that you can trust to do that. The other property is that it's tamper-proof. So satellites are in space after their launch, and they're physically inaccessible. So essentially, nobody can physically access them, extract things like cryptographic material or keys, or compromise the software to behave differently than it should, basically in a malicious manner. Third, it can be they can be transparent. What do I mean by transparency? So when they transmit, they can either encrypt communication to somebody specific that and only this party can get the data, or they can broadcast the communication in a way that multiple parties can see the broadcast and agree that that is what the satellite is transmitting. So think about something like say there is a some dispute about the most recent state of a blockchain, of some blockchain, and over something like a wired network or optical network, basically the way you connect to the internet, normally somebody can drop packet. A malicious, powerful actor can drop packets and prevent you from being up to date on the most recent, say, hash of the most recent block. So something like a satellite can help transmit it, broadcast it in such a way that multiple ground stations can see this communication, and it's very hard to block it over time such that you don't see it, and then they can gossip and agree on the most recent state. So that's just one example, but there are many examples of how it can be used for that. And the last nice property of the satellites we're talking about, which is cube satellites, and I'll show exactly how they look, is that they're low cost. They're low cost to launch and maintain. And that is due to advances over the past, say, 10 years in satellite technology and the cost of launching the thing into space. So this is becoming somewhat affordable, and that enables us to basically launch this technology at an affordable cost, not being some very large organization or a nation state, and basically keep launching those satellites so they can, so that we can create a constellation that can serve very interesting use cases. So in terms of how a CubeSat looks like, those are miniature satellites. They're basically a small cube. It's like 10 by 10 by 10 centimeters. And they're kind of made of pretty much off-the-shelf hardware components, but you still need to test it and make sure those components are suitable for operation in space. But the fact that it's standardized kind of creates a market for those standard components that you can purchase and makes it affordable. So it's small, but it's a fully functional satellite that can do useful computations. I just want to show how it looks from the inside. So this is kind of the CAD planning of the satellite. Essentially, it's this cube with a couple of boards inside of it. So one of the boards is what we call the other onboard computer. That does all the management and the cryptographic computations. And we're also developing a number random generator that's specific for operation in space and can harvest entropy that's caused by cosmic radiation, because we can actually harvest a truly Poisson distributed process that can provide true entropy versus pseudo-random number generators. So that's how it looks like on the inside. And in terms of some of the kind of business progress we made and essentially the practical use cases that we're serving, we're currently working with a few partners, and some of the notable ones are Velas, DoraHacks. So Velas is a blockchain. They're providing a platform for smart contracts that's competing with other blockchains. And there we announced a partnership around providing a verifiable random beacon. Essentially what it means is that Cryptosat, our satellite, will transmit random numbers, random bits from space, signed, and it's going to be signed by the satellite. So it's going to transmit them to a ground station. We'll feed it into the blockchain, and in the blockchain, basically everybody who needs some trusted parameters for things like, say, setting up a ZK snark scheme or something like that, or various things that require a random beacon, such as, say, a lottery or an auction, something like that, they'll be able to basically use our random beacon and verify through its digital signature that is created by Cryptosat, that it's actually coming from the satellite itself. And that basically enables interesting use cases in smart contracts. With DoraHacks, there's an interesting use case around trusted setups. So actually, while we're talking, this is kind of like a hackathon that involves voting on projects, and one of the goals is to have essentially privacy preserving voting, where judges or the community can vote privately, and that requires setting up a ZK snark scheme. So as part of it, essentially, one of the parties that's going to either contribute to powers of DAO or entirely generate entirely provide the trusted setup can be something like a Cryptosat that essentially generates it in a secure environment and then provides this common cryptographic parameters that are needed to bootstrap this ZK snark scheme. Defense is an example of threshold signing, where to sign a transaction, essentially, there will be two parties, one on the ground and one in space. So that's a use case we're working on with them. And with Protocol Labs, we were working on verifiable delay functions, which is the ability to guarantee that a certain amount of time has passed and feed this information into a blockchain. Because if you want something like, say, cryptographic, smart contract that tells that you need to move funds from one wallet to another within, say, 2 days, how do you know that 2 days have passed within a blockchain? You don't actually have a clock. So there's been a lot of research around the cryptographic verifiable delay functions, but there are issues there with the constants and kind of the range of time which those techniques can provide. So we're working on an alternative that's based on the physical constraints of communicating with the satellite at the speed of light. So yeah, I kind of talked about it already, so I can run through it quickly. So some of the use cases, as I mentioned, are random beacons, verifiable delays, trusted setups and ceremonies, and there are more use cases. And I want to dive into that a bit. So for instance, for the random beacon, or what's called the VRF, verifiable random function, the setup looks pretty much like that. We have the satellite that essentially generates, has a random number generator, generates entropy and transmits it to the ground station. And then the Cryptosat ground service would essentially feed it into its contract. So like if you're familiar with the Chainlink style oracles, that's essentially similar to that. So we'll run a smart contract and we'll call a set function essentially that will feed the new beacon into this contract. And then other user contracts would be able to call this contract and get this random beacon fields from it. So that essentially enables this nice integration between kind of like a non-Web3 infrastructure, like a ground station that can receive data from the satellite, from an outside infrastructure, and feeds it into Web3. The other thing is trusted setups for ZK Snark. So again, a very similar setup where there is a ground station. It sends a circuit. So circuit is basically, that's the computation, say with something like an auction or electronic voting. You essentially will convert your computation into a circuit over which you want to do those zero knowledge proofs. You submit it to the satellite, and then the satellite will generate the structured reference string for that, which can then be provided to users and verifiers to be able to verify the generated zero knowledge proofs that are run for those computations. Anonymous voting or private auctions, again, a very similar setup where we can say we can publish the public key of the satellite, and then everybody or the community or the judges can encrypt their votes to the satellite. The satellite will not disclose the votes themselves. It will just disclose the result of the voting procedure, and that can be fed back into Web3 or just publicized. And a very similar setup for private auctions. So just in terms of some of our progress, this last March, we had an experiment aboard the International Space Station where we were demonstrating some of those concepts, not in satellite, but in a module that was running the International Space Station. And there we demonstrated the connectivity with something called the DRAND network. That's a decentralized random beacon, essentially multiple parties that together are creating trusted entropy. And that's a consortium of different universities like EPFL, Cloudflare, Protocol Labs, and essentially we were this additional node and tested an operation of this additional node in space that can transmit its beacon and contribute to this what's called League of Entropy. The other thing we did is we essentially cosigned the transaction in space. So that was a real Bitcoin transaction that we could then post in the blockchain. And the idea that was that it's kind of a multi-sig, or in this case, it was actually threshold cosigning, and one party was signing on the ground, and we had this co-signature in space, and we're able to essentially publish this Bitcoin transaction. So kind of testing different concepts and how you operate and with such a system when you have this part in space with all the constraints of latency and bandwidth. And a nice thing we did as part of this was also this campaign where we enabled the users. We created this bot where we enabled users to essentially tweet at Cryptosat bot. So they would mention us and put some message, and then we would take this message and we would sign this space with the key that doesn't leave space, didn't leave the International Space Station, and we published the public key and therefore enabled users to verify that this nice certificate, they kind of got this cute certificate with the QR code that they could scan and go to our website to essentially automatically verify the certificate. The other thing we did and completed several months ago is the Cryptosat simulator. So that's essentially a way to onboard users and let them interact with the Cryptosat API and kind of learn about the different concepts even before we have a satellite in space or before they start working with the production satellite. So it's a combination of an interactive tutorial. There are basically those tutorials on the right that explain the different functions and use cases, and kind of JavaScript sandbox, essentially a simulation sandbox that enables you to call different functions, sign something, and get that feel for how this looks like. And actually, let me quickly show you how it looks like. Switching to the browser. Yep, so that's the Cryptosat tutorial. I'll create a sign-in request. I can sign some data. It can be arbitrary data. So here, sometimes it also simulates, it also shows the trajectory, a simulated trajectory of the satellite, and the blue dots are different ground stations. So now we see that the Crypto1, this satellite is green. It means it has connectivity, but it basically might also get out of range over the ocean, and then we need to wait for the request to complete. So first we check the status request to see whether it's pending or completed, and we see that the result is ready. Then we can access the result, which is in this case the signature and timestamp, and this is the digital signature over this ETH data. And there are multiple tutorials that go over the different satellite functionality, such as getting timestamps, getting public random numbers, signing data in space, and so on. So I'll get back to the presentation now. That was the Cryptosat simulator, and we'll keep maintaining it and update it with the various functions that as we go and develop the API. And the idea is that users can onboard in it, can play with the simulator, potentially even contributed use cases. It's an open source project, and come up with their own idea for how to use the satellite and submit pull requests. So that's something that we did some hackathons and bounties around. And that enables also to start integrating with it and then move into production with an actual satellite with the same API. Just wanted to show you also some of the initial assembly and kind of testing of the boards in our lab. So these are some of the boards, kind of the wiring. So this little thing, it actually, yeah, it's kind of the satellite boards. This on the right is you can see our logo among the different logos. It's essentially a collection of payloads that are going into space, and they're going to go to space this month, end of this month. We're going to have a launch along with other organizations like Brown University. So basically, we're on this kind of rideshare to space. And this company, The Orbit, is going to release our satellite, and it's going to be launched by SpaceX. So yeah, that's kind of it. Yeah, so I wanted to thank you. You're welcome to check more resources that are available on the Cointelegraph, our website, the different announcements. Happy to share those links. I'll paste them in the chat. And yeah, thanks for listening.
Great. Yeah. Thank you very much, Ian, for the presentation. Yeah. So definitely, it's a very exciting project that you are building right now. Some including the space. The blockchain in space topic. It's a super frontier, but one day we believe that definitely the blockchain technology used in the space would definitely be applied and add some value that cannot be achieved on Earth. So yeah, definitely looking forward to see how Cryptosat progress and revolutionize the whole industry in the future. Yeah, thank you very much, Ian.
Thanks.
Yeah, and we can move to the next project today.
Hello everyone, this is Kerry. Please allow me to introduce our project. Name our project is AntDAO. You can see that this is our logo. Regarding this, I would like to see 3 points. The first, Ant represents the spirit of cooperation. The original intention of our establishment of AntDAO is sincere and open. And second, Ants can lift objects that exceed 100 times their own weight, which means that AntDAO has huge energy and potential. Third, ants have a long lifespan, so the goal of AntDAO is long-term. Okay, let's continue. The next one. What's AntDAO? AntDAO is one-stop multi-chain token launchpad that provides completely permissionless, secure, and fair financial services. And let's take a look at our view. Number 1, AntDAO makes it possible for anyone to launch a new token to their communities by initiating the auction process of the token. The accessible launch enables any new creators or users to enter Web3.
Hi Barry. Sorry for interrupt. We cannot see your PPT is moving. It's stuck at the first page.
Okay, wait for a minute.
Yeah.
Can you see it?
Yeah, we can see it. Can you try to move to the next page?
Okay. Have a look at overview. Number 1, AntDAO makes it possible for anyone to launch a new token to their communities by initiating the action process of the token.
Hi,
The accessible launch.
Barry. So your PPT is still stuck at the first page. We cannot see your PowerPoint is moving. Like it always show the first page only. We cannot see the other information on your PPT. It got stuck.
Okay. I will again. This is our logo. I please allow me to introduce my project again. Can you see it now?
Can you try to move to another page?
Yes.
Are you moving? Well, if
Yeah.
you are, we cannot see it is moving. It is still stuck at the first page.
AntDAO makes it possible for anyone to launch a new token to their community by initiating the action process of the token. The accessible launch enables any new users and users to enter Web3 conveniently, even the users are not knowledgeable about other advanced technology. And part 2. Outside contracts of AntDAO are preordained, and anyone without knowledge of coding can open up a token action. Permissionless launch simplifies the token launch and fundraising process, increasing the liquidity for many users. And next one is details, features, and special DDs. Number 1 is permissionless. Anyone can launch a token or initiate a token action without any KYC or coding knowledge. This is a problem. Project parties, especially crossroads projects, have a low free share and more fair distribution method. All risks can't be ignored. The risks of new projects are huge, so you must participate carefully and balance the risks. Here is another question: how to choose a good project. Users need to have this ability. And coordination your work. And the next one is multi-chain based. Developers can deploy AntDAO on different chains based on their needs. Multi-chain coexistence, cross-chain interaction is a must in the future. So we will definitely deploy on multiple chains, including Park.chain parachain. And the third one is multi-chain interoperable. AntDAO is integrated to the cross-chain SDK of Stellar Network and chian to make cross-chain action into reality. Okay, let's move on to number 4. Action type optional. 3 types of action are available: cross, dash action, and bash action. Like in addition, from the process of new token creation, liquidity and transfer. Token emitted directly by VII. Token can be emitted directly. Creators can easily create ERC20 tokens with different functions through the token factory according to their own needs without knowing any code such as insure, or, and tax. And the last one is what listing. A what list is offered to help organize activities to the undefined entities. Let's introduce our team information. Our whole team has been devoted to build up the Web3 ecosystem in the past 3 years. A series of products are being developed as our ideas and the concept mature. Our tech team is made up of experienced technicians who are professionals in Web2 and faster learners and builders in crypto space. Our operation team includes marketing and PR staff who are proving success in their field. All of us work hard and closely to achieve shared goals one by one. We are all driven by the next project and hope to make a better one always. That's all. Thank you, Chris.
Yeah, thanks a lot, Barry. Although I think your internet is not very good. Some part of your presentation we cannot hear it very clearly. But yeah, thank you very much for attending the project demo session. And I think Judge will go through the project information later. Yeah, thank you very much, Barry. And we can move to the last project today. Hi, Lynette.
Hi. Can you hear me now? Oh, sorry. Okay. Sorry.
Yeah.
How about now?
Yeah, right now it's good. But
Really?
the voice is a bit small. You can, increase the volume. Yeah.
Okay.
Yeah.
I'll share my screen now. Okay, can you see it?
Yep.
Okay. Hey guys, I'm the Nut. Nice to meet you here. Now I'll make a brief introduction of Seavoting to you. Seavoting is a cross-chain decentralized voting system. In this system, anyone or any organization can create proposals without permission. This voting system, Seavoting, it cooperates with Cellular Network, this blockchain interoperability protocol, enabling a one-click user experience, accessing tokens, DeFi, NFTs, and more across multiple chains. Cellular Network and Seavoting can work together to conduct cross-chain voting, which is a great way to collect voting weights from contracts or wallets on various public chains. Meanwhile, users can benefit from this diverse multi-blockchain ecosystem thanks to Seavoting by simply setting the address and weight of each blockchain and contract. The weight can be calculated in real time in the voting. For users, it is fairly convenient. At present, various types of DAO organizations have chosen Snapshot as their tool of voting, but actually Snapshot still has many shortcomings as of today. One of these shortcomings is that it can only be used in off-chain voting. When it comes to on-chain voting, snapshot just doesn't work. Another problem snapshot faces is that it can only read the data stored in the wallet. For example, snapshot cannot read the number of tokens in smart contracts. It can only read the number in the wallet. However, in fact, governance tokens are typically distributed in different smart contracts. So to solve this problem, Seavoting came into being. With Seavoting, an NFT voting system can be established. In addition to reading the number of governance tokens in the wallet, it can also read the number of the token in the specified smart contract of the corresponding blockchain and customize voting rights for different smart contracts. As a decentralized cross-chain voting system, Seavoting primarily has the following 4 features. First, Seavoting is fully decentralized. In this system, voting is done through on-chain voting. Second, more than one resource of voting weights are offered. Users' votes in Seavoting are not confined to their wallets because their votes can also come from the smart contract. Third, you can have different voting weight in Seavoting. For different contracts, users can set different voting weights as they need. And lastly, in Seavoting, you can see great flexibility in cross-chain weight collection. Among all blockchains available for their voting, proposers of this voting event can decide which blockchain the voting weights come from. It can be one or more than one blockchains. Apart from this, proposers can also determine how many voting weights each blockchain they have chosen has. That's all my presentation. Thank you.
Great. Yeah, thank you. Thank you very much for the presentation. Although it's not very too long, but it explained your project information very well. Yeah, thank you very much. Yeah, so I think we can end it up here. Thanks for all 3 projects that are participating into today's project demo session. It is very useful, session for judges and audience to better understand what you guys are trying to build right now. So yeah, thanks for attending us today. Hopefully you guys could keep building and kickstart the next best products in the industries. Yeah, thank you guys very much, and good luck in the future, and have a good day.